Now, for today, what I want to work on is rewriting the physics engine. So yesterday, I was thinking about like how I want to do the falling, how I want to do everything else. I ended up realizing that I sort of put myself into a corner a little bit. Refactoring it would probably also been an option, but I think it was a little bit easier for me to wrap my head around what happened with just starting from zero again. But this time starting gravity first. So I began that a little bit last night, or I guess not night, but yesterday evening. And this is what I've got so far. We have um, the ability to. I only have 3 tests, but those tests are growing in complexity and size. So basically, our creation test, um, the get state test, which I mean that doesn't really mean anything else, and our physics state systems physics test, the update function. And so this is basically handling all the different cases. And because of that, I now can see I don't have any errors. I can run this. I do have a weird little thing with jumping. I'm not exactly sure what that's going to look like. Um, but okay, so I can jump here, and I'm on the surface. I can't move yet. I haven't implemented that yet, but we're going to get to that. If I update our right here and we start on surface false, then that makes it so that the current floor that we're on is the cave, and now I can jump here. Jumping multiple times is a little bit interesting, so I'm not exactly sure why this happens, but only in the cave. I think it's... Oh, I can jump while I'm in the floor of the surface. Okay, I see what that bug is. And if we take a look at how we're doing this. Here's our handle command jump here. So if our location is, and then it's the surface floor, I really need to track the the floor that we're on currently for jumping, and then that would be a lot better. Now what I could do is I'm actually surprised we could jump at all. I guess that means that the top of us is clipping into the floor from the cave, and that's the reason why we're able to jump. Oh no, greater than or equal to, as long as we're down on the floor. Okay, got it. So probably the best thing to do here would be to swap out which this surface floor is based upon what which state we're on. So we want to do for y is equal to if self dot on surface. Okay, so if we're on the surface, we're doing self dot surface for y. Otherwise, we're doing self dot cave floor y, and then you can just be floor y. I think the test should all still pass. I think that's because I didn't really think about. No. Oh, I'm off by 1. Bootsby, hello. I know this is annoying observation after a high volume incident, but your overall stream volume level has dropped significantly recently. Your general commentary is now very quiet compared to VODs. Oh no! I think it's because the way I set up my desk, the microphone is just slightly farther away from me. I can maybe move that closer, like that. Okay. Does that help at all? Let me also say, oh man, how did my mic? Okay, you go full volume again. Apparently my mic volume was lowered slightly. And I see that, yeah, I'm very rarely going into yellow anymore. Previously, I was like every once in a while peeking in a red, but for the most part, staying pretty solidly in yellow. How does this sound? And oh, I think it's fine. The high volume incident was because I switched my speakers to a cable out of the display that I have, and for some reason, uh, that actually pays attention to the Windows uh, volume that I have. Before, I could have the Windows volume set to whatever I wanted, and OBS didn't seem to care whatsoever. It just sort of played it out at the volume that the audio source wanted, cared about. So suddenly, I have my Windows volume up, and bam, it hit really hard. It was just so low that he couldn't correct without increasing the volume of my physical output, which I hate doing. Yeah, I hate doing that too with streams. Then I hate like when you have to like constantly adjust back and forth for the same video or stream. So thank you for letting me know, and we'll keep on working at that. I think I'm able to bring my split keyboard back down, which allows me to bring my microphone closer to me because it goes in between the in between. I do own like 90% of an arm that I could attach to the desk. I'm missing one piece out of it, which is lost somewhere in a move I did many years ago. So I can't actually attach. It's either I can't attach to the desk or I can't attach the microphone to the arm, which sucks. And I've just been avoiding figuring out exactly what piece that is and then buying the new piece. All right, so I need to figure out let's see. So this is line. Why do I get the idea that line is a lie? I don't think I have 112,000 lines in this file. Just a guess. What is going on with this? That's okay. So we're off by a couple of these. Perhaps I should break these out to their different test sections. So for right now, it's just basically an update with nothing happening and gravity gets applied. Then an update in which I jump, like I start jumping, and then I'm no longer jumping. I guess we could have that we're standing still. That could be something that we're doing. And then that I can stand on the cave floor is these things. But if you're going to freak out, well, let's try. Sure, we need to test manually. Okay, this is a much better error. 135. Okay, so this one right here. So we might need to run this twice here to make sure that you know what? No, I don't. The reason why these tests are failing is because I've set myself to be on surface false. If we set this back to true again and we run these tests, then we should be happy. Yeah, okay. So that's the problem there, is that I was falling through the floor because I had set this to false. But now our jump should be fixed. So when I jump, no, or go run. when I jump, there's my jump. So this actually feels a little bit better. I'm also thinking I'm probably gonna have to reduce the size of the player. That's gonna be a little bit annoying. But something we can probably do. So did not need to hit Alt F4. Document builds. I'm so used to hitting Alt F4 at that game, but then I already had done that and I just pressed it twice. So that's always fun. All right, so we can reconnect you. All right, so I want to now make it so we can move left and right. So with these tests getting a little bit complicated, let's break this out a little bit. We're gonna test CI test, player, physics, state, move right. So in order to run the update, I need these three things. So I need their player physics system and the config. I just have a helper function here that gives us those. The config is a default config, and so I'm able to play around with that. Maybe have like slightly different numbers than the real config has, but that makes it easier for testing. Location. Okay, so we just have the starting location here. Right, okay. So if I'm gonna player that we move right, we're gonna make you have a sum command move right. We're gonna have no features. We're gonna test. We're gonna run update, and we should be to the right at the end of that. So that should be player physics system update. Give it a mutable reference to the location. Give it the command. So I'm gonna actually name you right command. And features. So then after we do that, we should expect ourselves to be whatever our move speed is, one to the right. So do we have our speed stored here? We do not. So let's go ahead and add that in. So that'll be this test here. Equal speed is config dot player speed. You'll be an F32. And you'll be config dot player speed. All right, back down to these tests. Okay, so after we update, we should insert equal that the player physics system dot location. No, we don't have to check that at all. We should check our location. Should now be equal to a new point 2. And our x should now be to the right, so we would expect this to be our config dot their speed, and then our y to be exactly the same. So I'm actually going to give you a 0, 0, so I'll make it easier here. We also expect that our state should update. So my physics system dot state should now be physics state moving right. So we can run U. We also need to make sure that we're on the surface true. So you failed because we are not to the right. Okay, so the speed in the default must be 10. Yeah, because that's this one. Okay, so let's go ahead and handle that. So here, if our command is move right, then we want to check to see, can we start moving right? Probably. I think that we probably could. So first thing, we set our state. So self.state equals physics state moving right. And then we also set our velocity. Self.velocity dot x plus equals self.speed. And then this part where our location dot x plus equals self.velocity dot x. Okay, so that should help there. Let's go run this test. Okay, so you're right. We can compare the x because the y we're actually falling. So we do expect you to become 1. But what I can do is say that we want config.player starting y. And do the same thing here. And we shouldn't fall anymore because we should hit the ground. Let's see. Left is standing still, right is moving right. Okay, so apparently that's not updated. Standing still and moving right. So on the left, and this is on 178. Yeah, okay, so our state is standing still, and we want you to be moving right. I thought, I know what this is. Our problem here is that when we collided with the ground, we reset our state to standing still. So I think we should only reset our state to standing still if we actually are jumping. Otherwise, we should still be moving right or moving left. And that's interesting. So, or we could have like two different states. We could have like a move state. That seems wrong here. The only reason I need that is because the controller's not able to I have to give like separate events based upon which of the controls are pressed. Like if I have to start pressing it and then release pressing it, those are two different events, which sucks. So that means two different commands. So maybe we should have a horizontal movement state. So it could be multiple states. which means we can have like a jumping true. Yeah, I kind of like that. We have a jumping true. So this state here, based upon physics state, what are my options? Falling, jumping, moving left, moving right, standing still. I can also store my previous state, like my movement state, and then sort of swap back and forth between them. So as soon as I hit the ground, we just go back to whatever the previous state is. So we collide with the ground. We don't want to go to standing still. We want to go to the last sort of standing state, as it were. And I guess that could be it. We could have a standing state, and we can have a jumping state. And jumping state would be falling or jumping. And then our U will be standing or running. I don't like it. I'm not exactly sure what's the best way for me to go with it. I might just choose one arbitrarily and go there. Basically, if I store a running right, the state, we are tracking. It feels like we're not really tracking this for like that's mostly for the graphic. Like maybe I want like the graphic state of what graphic I want to be displaying, and that's what the get state is going to return. But then the actual graphic, like the actual state that we're moving in, I don't know if that makes sense either. So basically, we're running. We, in this case, I didn't even jump. We just moved right. So we took one step, we moved to the right, we hit the ground again, and that reset our state. So to me, if our state is moving right or moving left, we only want to reset this to standing still from a jumping state. I guess that's what we want to do here. We can refactor this a little bit too, because I think everything is exactly the same, except it's the surface floor cave floor. So I can actually refactor this at the same time. And we have tests that cover it. So let floor y equals if self dot on surface dot surface floor y else self dot cave floor y. Then we don't need this entire if on surface, but we could just have this one if statement here. And you're going to be on the floor Y. So not K floor Y, floor Y. So reset yourself to the floor Y plus half your height. Set your velocity.y to 0. And then, okay, this state has to change depending upon if we're in. Okay, so this is going to be if self.state is a jumping or a falling state. So in that case, we were doing a jumping. Then I want you to be a standing. So let's see, physics state, standing still, else, whatever the state is. So actually, I think I could just do that. We reset you if necessary. Oh, okay. I can't. Oh, right. I could do an if statement to reassign then, but if I'm actually reassigning this, I need to then just say self.state. Okay, so that makes this a little bit cleaner. Now, if I run you, you pass. That's good. And if we run all the tests, you pass. Yes, perfect. Okay. Okay, so that means we should be able to run right now. And there we go. We can run right. We can't actually stop running right. So that's a thing. So that would be next. And it's probably move right. So we want to be able to stop moving right. So that means now creating a stop moving right command. We're going to update. The application. This is going to be the stop moving right command. Features is fine. We do have to clone this one up here so we can use that one again. Okay, so we now have. Okay, so we updated again. Now we have a stop moving right command. I would expect that our location should be the exact same location as before, and everything should be fine with that. So, start equal. First of all, our state should now be standing still. So, system.state. Now we should definitely be physics state standing still, and our location our location should now be a point to. It actually should be the exact same location that we have here. Right, and so it's yelling at us because we're still moving right, and we should be standing still now. So let's go ahead and implement that. So that's this command here. So at stop moving right, what happens when we stop moving right? We want to set our velocity. So self dot velocity dot x is 0.0. So just immediate halt to this. And then also we want to now we're on the ground. So if we're on the ground, that's when I can set ourselves to interesting. Yeah, so I guess like with my state system here, because I have it as a finite state as opposed to like multiple states, that could be a problem. Because the way I have it, we can be jumping and moving right at the same time. How do I track that? I don't know if there's a super good way of the system that I have right now, but I think I might have to have like a jumping state and a movement state. And that way I can have two states at the same time. All right, so, and essentially they're flags at that point. Are we jumping? Are we moving right? Are we moving left? Okay, so velocity x. Okay, so then we want to, just to make the test pass for this, let's say self.state is equal to physics state standing still. But I foresee a problem once we go to the graphics engine for this. And run you. And pass. Okay. Let's refactor this a little bit. We're our handle command is getting a little bit long here. And that's mostly because these, as we fill them out, they're getting a little bit crazy. So this one is handle jump command. We have self. We do need location. Maybe what I can do is create a handle jump command. Self, and we'll have our location. We won't turn anything, and we're just going to take you. You move you down into here, and here I'm going to place you with a self dot handle jump command and pass it in location. All right, then. Everything should still pass there. Let's go ahead and run all these tests. Perfect. Let's see. I suppose we can do that with all of these. Refactor these out to their own functions, and then this way just calls which function to run. So here is move right. So function handle move right command self and location. You go down there and you self dot handle move right command. Let's see, what's next is this stop moving right. and throw you in there, and then run handle stop right command. There you go. Okay, so then as we need more of these, we'll then fill them in. And all of our tests should still pass. Everything should be happy. And they are. Okay, so let's see. We're happy there. That's good. That means we should now have a move left. So I should be able to duplicate this test completely. Where we're now update move left. I should be able to... Oh no, it's not going to be quite as easy as that. Okay, so left. We're going to get our player physics system and our config. We're going to get our location. We're going to set it to 0, 0, and that's going to be fine. We're going to have our move left command. Okay, so some command, you're going to be move left. We have no features. We update player physics system with the move left command. Assert equal that we're now at a negative there and starting Y. Okay, so that should be good. And now we should be moving left. All right, let's stop moving left command. Stop moving left. We update. Now our state should be standing still, and we should be at the same negative position there. All right, so run you. We should be at negative 10. All right, perfect. Let's go handle that command. So following this exact pattern here, I should be able to just write this function here. So function handle move left command. And we're going to move left command, self dot handle move left command. And now we're going to do the thing. So I think it's going to be very similar to the handle move right command. We set the state. So self.state is now going to be equal to fit physics state moving left, and self.velocity x is going to be minus equals to self.speed. And then we can have a stop moving left command. So we don't actually need a location in any of these, I noticed. So we can make it so we don't actually pass these in. Only the handle jump command really needs that. So that's you. All three of you. So handle stop moving left command, you. All right, what's gonna happen? we'll just for right now switch back to standing still. Self dot state equals physics state to standing still. Self dot velocity x equals 0.0. All right. And all of our tests should still pass. Perfect, which means we can now do a cargo run, and we should be able to run left and right now. Excellent. So next up, we can jump to. Our jump feels just as, actually, just as tough to make this jump as the real game. The real game is like almost pixel perfect, it feels like. So maybe this jump will be fine. We want to be able to fall through the pit. So how is that going to work here for us? I want probably a new test for this. CI test air physics system falling into pit. All right, so first of all, we need the new physics system. So we need you to run the update command. So we need all of these. That's fine. We don't need that exact command. But we need to place ourselves over a pit, which means that our features, we need to add a feature too. So that's going to be fun. Let's create our feature and add it in here. So that features equals a new vac, and inside of this vac, we need to create a game object. Oh, actually, I think we can just do a create pit. Okay, and we just give it a reference to the config. Okay, that's easy enough. And then we unwrap it. All right, so here's our feature with a pit in it. Now, I need to figure out where exactly to place the player so that they fall into the pit. I suppose to begin with, if we have config.player starting X. Okay, so if we start the player where they're supposed to start, even if we have a pit present, they should not fall in. So we're going to have no command. So that no equals none. We're going to run update, and then everything should be pretty much exactly as it is. So let's see. Physics system update. Will reference the location, the command, and the features. I'm going to clone this if I can. Oh, and you're our no command. Right, you're just yelling at me because you don't need a clone. Yeah, I'm going to run you again. Don't worry. Okay, so then we're going to assert that we're still on the floor. So our location should be exactly the same as what it is right now. So then assert equal location should be equal to you. Okay, so this shouldn't be failing yet. Like, we haven't run any code that will fail. So Next, I want to reposition myself over the center of the pit. Run an update, and we should go down by 1 pixel. So that means our location dot x. We now want to set this probably halfway across the pit. We have the pit right here in features. So let's see. Can we do features position 0 dot location dot x, and I think that's going to be the center of the pit. So our x. Okay, so we're exactly over the middle of it now. We run another update. And now we expect our location to go down by gravity. So our y should be player starting y plus player physics system dot gravity force. Six errors. Why am I getting you as errors? Okay. You're not real errors. Yeah, you went away. Okay, never mind. Oh, we need to update our x for that test too. If we're going to update our x manually, we need to make sure that we are also, let's see, our location after we updated this should be here still. And so that means only the y should be different. Yes, okay, so we're down by 1 pixel. So we did fall. No, we're telling it we should have fallen, but we did not fall. Okay, so that's what we're gonna happen now. Okay, so how are we gonna do this? We have our update here. Now we're finally gonna deal with our features. I'm just gonna put this in here, and then we can refactor afterwards. So based upon we know it's only pits right now, but of course it's going to be more things later. And maybe the physics system needs to be aware of like what type they are. So it's probably going to be lots of different little functions to sort of handle this. Right now we can loop through all the features. And I guess when do we want to do this? Probably after we've handled the command, before we've hit the ground, and before we've updated our location. So probably right here. So we can loop through all of the features and then handle each of those features individually. So we can do a features dot. I don't think that we're going to mutate them. So we can just get a iter for each. We have a feature. Then for this feature, if it's a pit, so we're going to have we have the feature type, and it's probably going to depend upon that. So maybe we can match on the feature dot. There's my type, but we also have feature type. Oh, it's a sum. Okay, so we want to extract that out first. So if let sum feature type equals feature feature type. Now we can match on feature type. Peyton rules rating with a party of 3. Hello, Peyton. How's it going? How's your raid? How's your stream? Mayo Cat. Hello. B Porter. Hello. Yeah, what are you working on today? And how did it go? In the meantime, while we're waiting for Peyton to answer, we're going to play the Get the Streamer game. It's what we play when we get raided. So it's going to be a chance for all of you raiders to attack me. So I'm going to hit this. You're detecting the operating system and running the right OAuth code. Oh, that sounds fun. All right, for this game, you're going to do commands in chat equal to these over here. And so like fire and then a column, or you could just leave it off and it'll be random. And I'm going to try to avoid you completely. And we'll see how we'll see how long I last. Oh, I didn't notice that was a snake. Thank you, Raven Legend, for giving me a little bit of a reprieve there. Had to trade some iframes. Oh, I thought I could go over it. Oh, man. Okay. You all won. I didn't even get to the halfway point with B Porter with 52 points. Awesome. Yeah, so that actually sounds really interesting, Peyton Rules. Is that part of your Godot game, or I guess to do app? Is the OAuth that you need? We have 2 errors here, so I can't show you this game yet. We need to fix these because we're right in the middle of writing this feature where it can fall down into a pit. But we are making a Pitfall clone, so falling into a pit seems like it would be pretty essential for this game. Okay, so let some feature. Okay, so we get the feature type. We're looping through it. You need to be semicolon. Part of the Godot app, yes, it's using GitLab's OAuth, which works different on the phone versus the Mac. Oh, interesting. I haven't done any native coding for phones. I usually just do web apps for phones, and then that's good enough. So yeah, that sounds like actually an interesting problem. Okay, so if we're a pit, then what do I want to have happen? I want to check our location. If we're over the pit, we fall down. So location.x. Now this is going to be the center of the location. So the left half of us has to be to the right of the left edge of the pit. So this is fun. So if location.x minus half of our width. Well, do we have a width? We don't. So we need to add that in. Okay, so now we have our width. So self.width divided by 2. Okay, so that's the left-hand side of us. If the left-hand side of us is to the right, so that's greater than the left-hand side of the pit. Okay, so that's going to be this specific feature. So feature.location.x plus feature.width divided by 2. Okay, so our left is to the right. Okay, so then we're the right edge of us has to be to the left of the right edge of the pit. So I think I did this incorrect here. We have to be greater than the left edge of the pit. So that's a minus. Then our right edge needs to be to the left of the right edge of the pit. Okay, so then it's going to be location.x plus self.width 0. Now that needs to be less than feature location.x plus feature.width divided by 2.0. Okay, so if this is true, we're fully xy's inside of the pit, which means that we're no longer on the ground. Now, what's interesting here is that we already have this entire affected collide with ground. We actually just want this function here to be updated to not hit this. So we need the ability to, before we hit collide with ground, are we over a pit? And that this could be a flag. This could be a flag. So we could do is over. So let's, if we're doing this as a flag, let's also add this into our test. Okay, so is over pit. Then this will be, we want this to be a false to begin with. We're not over a pit to start. Okay, then in here, all we're doing is we're setting that flag. So self.is over pit becomes true. And I suppose we can just set this to be true or false here. Because can we just say self.is over pit equals to the result of this Boolean here? I mean, potentially. I think if we don't have a pit, but we like somehow did have a pit, I think because pits are not going to be at the edge of the screen, I think we're going to be fine. But that's our test will hopefully help us, or at least help us refactor if we do run into problems. Okay, so now we're going to be over the pit, and then that means that in order for us to fall, in this collide with ground, we need to also check to see if we're right here. Okay, so if we're touching the ground, what's happening here? Here's our if opening. Then we set ourselves. So we want to not touch the ground if we're on the surface and we're over the pit. And I think that's the issue here is this is our transition into no longer being on the surface, or at least one of our transitions. So we hit, I wonder if we can just check our Boolean here, and then we essentially just don't collide with the ground if we're, okay, so if self dot on surface. Okay, so if we're on the surface, then we don't need to do anything, right? If we're on the surface and we are over the pit. So now there's a problem. If we jump over the pit, I don't want us to transition over. So we have to actually be colliding with the pit. That's what we have to care about, is are we colliding with the pit? And I wonder if that means that we should pass in our features into collide with ground just in case any of them are pits. And then that way, collide with ground, collide with pit. That way, if we're overlapping with the pit, that's when we transition our surface. Like, we're no longer at our surface. Now we consider ourselves on the ground, and that's our new floor. I kind of like that idea. So let me write that out in comments here. So if we collide with a pit, then we are then we reset floor to the ground. Hey Chantilly, good morning. To the cave. Reset floor to the cave floor. And we really only need to check if we're colliding with the pit if we're on the surface. All right, so if we collide with the pit, then we reset floor to the cave floor. And then we probably also want to like collide left and right, but I'll handle that in a little bit. But for right now, I want to somehow pass in the features, specifically the pits is the only thing we really care about here. And is that true? I think it's probably going to be all the features. So if we have features, and you're going to be a vec of game objects, like that. What are you right now? You are, yeah, you're a vec of game objects. And we own you because you're light clones. Specifically it's a pit. And that's what we care about. So I don't think we're gonna want any of this stuff here. We don't need to do that. Up here is where we're caring about. What are you upset about? Right, we now need to pass in features. Okay, so you're happy there. Mismatch types. Expected a vec of game objects. Oh. I think I did this wrong. You are a vec of game object. Not game objects. Okay. There we go. No more errors. So we have to check to see. So we know what surface, like the surface floor is, based upon where we are here. If we're on the surface, we have to check for pits, and all those other features that are above ground. I suppose we might need to check each of these specifically, and then we can handle hitting the floor and the ground. But okay, so collide with ground. Let's say for let's see, for features right now. So in this case, maybe I don't need that is over pit, because we're gonna have that in here. We need to loop through the features, and then for the pits, check to see if we're over the middle of it. If we are, we don't run this. We don't run this. Like we don't check to see if we're hitting the ground, so we don't switch ourselves to standing still, and we don't reset our velocity Y. We just continue to fall. And I think that's what we're gonna do here. But we only need to do that for pits if we're on the surface. So we might need to reset some of this function here. All right, so let's try this. We're on we start on the surface. Let's just imagine we're there. We're going to loop through all these features. So features.iter for each. We're going to have a feature. It'd be helpful if I spelled this correctly. For this feature. Okay, so then we need to figure out what the type is. So that some feature type, feature dot type. Okay. Now we have our feature type. If this is a pit, So I think we can match the feature type because that's an enum. Now it's only one thing right now, but okay. So let's say you're a pit. If we're over the middle of the pit, so if we're colliding with the pit, and that means standard AABB bounding box. So if the bottom, if we're we have to be fully enveloped. No, that's not true. We don't have to be fully enveloped in the pit. We have to be, okay, our X has to be, so the left-hand side has to be greater than the left-hand side. The right-hand side needs to, okay, so let's do this one little bit at a time. So the left-hand side of the player, well, and that means, okay, so we have our location, we have the feature, so perfect. So we can do if location.x, and we already just did most of this, but we'll just do it again. So the location x minus self.width divided by 2. So the left-hand side of us, if that is greater than the left-hand side of the pit, so that's going to be the feature dot location x minus feature dot width by 2, and the right-hand side of us, location dot x plus self dot width by 0, if that is less than feature dot location dot x plus feature dot width 0. Okay, so we're fully inside of it on the x. Now we need to check to see if our feet is below the top and our head is above the bottom. Is that right? So if I'm colliding with something here, so let's say I'm colliding with this sticky. So if I'm like this, the bottom, I can even do something like this. So the top is below the top. The top is above the bottom, and the bottom is below the top. Is that right? The bounding box, it always confuses me. I always like sort of get a little bit turned around in it. But basically, to ensure that we're connecting, the bottom of us has to be below the top. Otherwise, we're just fully above it. So that's going to be our location.y plus self.height divided by 2.0. Okay, so that's our bottom. You must be greater than feature location.y plus the top. You must be below the top of us. That's minus feature dot height divided by 2.0. Okay, so the bottom of me, my feet, are below the top of you. But at the same time, my head must be above the bottom, so we're not fully below it. So, and location.y minus, so for my head, self.height divided by 2.0. My head must be above, so less than feature dot location dot y plus feature dot height divided by 2.0. Okay. We're colliding with. So we're now colliding with the pit here. If we're colliding with the pit, what does this mean? We want to now, if we're on the surface, we now want to flip this to be we're on the floor. So if self dot surface on surface, we then want to be self dot on surface equals false. And then that will have us start falling through the floor. And I think that will work for us. You're yelling at me because we can collapse this into easier. Oh, I can probably add this into this if statement here. I want to move this into its own function. But to begin with, does this make the test pass? It does. We fell. Okay, and that means that I can now cargo run. We can run this, and I can show you off what the game looks like. All right, so here we can run, and then we hit the pit, and now I'm running here, and I can jump. We do have some weirdness with the jumping, so we're gonna have to figure that out for the graphics. We're also going to want to have like an actual jumping animation. So I think we're going to have to update that when we get there. But awesome. Now, can I jump over the pit? Oh, not quite. I don't have a way to get back up yet. If I jump earlier. No, because the pit is up here and I'm fully touching it. And so I'm really only caring about this number here at like this level, like whatever my surface level is. So if we have a pit, I don't actually care about the top of the pit. I care about this surface here. So what does that look like? So I don't want to set on the surface to false unless I hit, let's see. We don't have to go all the way to the top of the pit, do we? So wherever we say the feature minus height, we actually need to do I think we might also need to like add something in there. So if let me just look at this again. We have an invisible floor line coming through like right in the middle. Oh, right at the bottom of the pit. Oh, the bottom of the pit. So we can just do all of our calculations based upon this. Oh, that makes it a lot simpler. So, because like our feet are here at the bottom of the pit. Like that. I can even come here It's only when I go in fully in. So we get a little bit of extra space. But I need to check. I don't need to check the Y. If we're enveloped, yes, in the pit, and we're standing on the floor, that's when we need to switch over. Okay, so this changes a little bit. I suppose this could be if we're colliding with the pit. So let's actually make this like a colliding with function. Is colliding with we'll have self and then a game object. So we'll have other, which is going to be a reference to a game object, and we're going to turn a boolean. And so we could do this entire bounding box collision here. So we're going to return you. We do need location. Then instead of feature, you become all right. So you're happy. Then up here, so if self dot is colliding with location, the other is the feature. Right there, that updated that. A little tall for the bit, aren't you? Or is the pit a little small? You'll never get over the scorpion. I'm gonna have to manipulate it a little bit to figure that out. I haven't made the scorpion yet, so maybe we can make the scorpion really small, and then we can do that. But yeah, I am a little bit tall for the cave. I think we may have to change our size so we can jump higher, or just make this scorpion really small. Sort of deal with that. We're already just step over it. I mean, at this point, we can just step on the scorpion then, right? We're just so huge. Okay, so self is colliding with... Okay, so if we're colliding with this this one, we also have to check. So if we're colliding with it and we are below the surface. So and our location dot y plus self dot height divided by 2. So our feet are below, our greater than, and then this is, we need to have up here, the floor y. If that is the case, then if self dot on surface, okay, what are you upset about now? If there's no and here. Okay, so if we're colliding with the feature and we are below, our feet are below the surface, the floor, then, so I can combine these together, but I think this will make it, so our test should still pass. I don't know how nice are Harry Pitfall shoes. I have no idea. All right, so what are you upset about? You're upset because you fell into the pit. You fell into the pit on line... Oh, it panicked. No, left as goes right. Wait. What? Don't remove where. Okay, so move right. Move right. What? We don't even have a feature in that test. So you shouldn't. This shouldn't be tripping. And these should be just fine. Let's see. I didn't set ourselves to on surface true. Okay. Actually, just run this and see. Okay. You can fall into the pit. Can I now jump over the pit? I can. I mean, a little bit of graphics glitches, but we haven't figured that part out yet, so that's fine. So I can jump over the pit now, and I can fall into the pit. Okay, perfect. So I need to figure out in these tests, what have I done to cause that to be upset? So in player moving right, we let's see, we run an update with no features and our location while we're moving right, and we expect that we move right, and we fell down. And that's our problem. Which is strange. Which one of these asserts was the one that actually failed? Oh wait, you passed. Okay, hold on. Which one failed? Oh, it's 8:33. I think I'm gonna have to go pretty soon. 283. Here we go. Assert equal our location. Okay, so we're testing falling into the pit. We placed ourselves over the pit, I believe, at the starting Y, so that should be fine. Oh, we need to move into. Now that should put us in the center of it. Let's see. Features has the pit in here. Okay. So I'm thinking, why am I not? Let's see. Run this again. So 283, that is that one. So our location is 960, 710, and we want to be at 711. I wonder if it's just a problem where I need to run update twice in order for it to take effect. That's what it was. Basically, I dropped down one, but it wasn't enough. I needed to go one more update, and then we dropped down. Okay, so we're happy there, and that means that we're now now able to fall. So next time, I think what I want to do is when I hit the edge of the pit, I stop my horizontal movement. So if I'm colliding with the pit, stop the horizontal movement so I can't, like, I can't. It doesn't look like I'm falling through the floor. Um, but that's gonna have to be next time. Let's go ahead and clean up our warnings here. Okay, so falling never happens. You're just gonna have to be fine with that. Game objects, so we never. I accidentally brought you in. So falling, we can remove you because we're never in that state. It's pretty easy to bring that back in. Okay, so is over pit. We don't actually need this ever. Because we have a different way of checking to see if we're over a pit. Okay, so if statement can be collapsed. So you want me to combine these two. So if we're colliding with and this location, and then I'm guessing another and self on surface, then become that. And then we need to remove one of you. There we go. Unuse that comp. Yeah, I definitely don't need that comp. And no more problems. Okay, so we're good here, which means we can close all of these windows and send this on up to GitHub. All right, so we are can fall into the pit. Next time we want to collide with the sides of the pit and stop our horizontal movement. Horizontal movement. Okay. And I'll push that up. So I'm in the branch 31, allow the player to jump over the pit, and that is at Bang Repo. So if you want to go take a look at that code, it is over there. With that, it is 8:38. I've got a meeting coming up very shortly, so I've got to head off to my day job work. But I will be back again tomorrow in order to continue working on this. I am working after work. I'm spending about an hour or so working on this, just so that I can get I'm not going to finish the game probably before I have to ship this off. But I am going to be hopefully be able to get at least the basic gameplay in before I ship this off as the gift. And then maybe we'll have a 45 gigabyte day one patch for him. I don't know. We'll see. Anyways, with that, have a great rest of your day. I'll see you all tomorrow morning. Bye.